Hello, my dear students. Good afternoon. Today we are discussing the important question answer from the chapter metals and non-metals. Already we have discussed some questions related to this chapters. So this is the next part of that chapter. Okay. So let us start with the first question. Explain the formation of ionic bond between the sodium atom and the chlorine atom. So that is the atomic number of sodium is 11 and the chlorine is 17. So you have to explain the formation of the sodium chloride, the bond between the sodium and the chlorine atom. So this question already we have discussed in the last class. So please go through that video. Then second question is list any four general properties of ionic compounds. Please note down this question. List any four general properties of ionic compounds. Here, what is the physical nature? Ionic compounds are solids and somewhat hard because of the strong force of attraction between positive and the negative ions. These compounds are generally brittle and break into pieces when pressure is applied. So that is the physical nature. Then what about the melting and boiling points? So these ionic compounds, they have high melting point and the boiling points. This is because considerable amount of energy is required to break the strong interionic attraction. So that is the second characteristics of the ionic compound. The first one is the physical nature and about next one is about the melting and the boiling point. Next question, solubility. Next one, that is the electrovalent compounds are generally soluble in water and insoluble in solvents like kerosene and the petrol. That is about the solubility of the ionic compound. And conduction of electricity. So these ionic compounds, when they are in the molten state, the ions are able to conduct the electricity. But when they are in a solid state, ions are not there. So the electricity is not carried by this when they are in the solid state. See, here, the conduction of electricity through the solution involves the movement of the charged particles. A solution of an ionic compounds in water contains ions which move opposite electrodes when the electricity is passed through the solution. Okay. Then, but ionic compounds conduct electricity in the molten state. So this is possible in the molten state since the electrostatic force of attraction between the oppositely charged ions. But in the solid state, it is not possible. Next question. What are alloys? Name two alloy of copper. Note down this question. What are alloys and name two alloys of copper. Here, an alloy is mixture of two or more metals and two common alloys of it may be two or more metals or metal and non-metals. Okay. And two common alloys of copper are, so the second question is here. Name any two alloys of copper, right? So here the two alloys of copper are brass, which is made up of copper and zinc, and the bronze, which is made up of copper and tin. This is made up of copper and tin. Okay. Next question. What are amphoteric oxides? Give two examples. What are amphoteric oxides? Give two examples ಅಂತ ಇದೆ ನೋಡಿ. ಇಲ್ಲಿ amphoteric oxides are oxides that have both acidic and basic properties and can react with both acids and bases. So they react with the acids and bases to form the salts and water. So they are called as amphoteric oxides. Please note down this. Examples, aluminium oxide and the zinc oxide. So they are example for the amphoteric oxides. Next question. Draw the diagram of arrangement of apparatus to show the action of steam on metal. One of the very important diagram from this chapter. Please note down this question and important diagram. So which is repeated in many question paper. Okay. Next question here. 250 ml of water is taken in a beaker and beaker A and beaker B. About 5 gram of sodium metal is added to the beaker A and 5 gram of calcium metal is added to the beaker B. What are the reasons for observation that have been noticed here? These are the two beakers. Okay. So this is the beaker B. Beaker A and beaker B. Okay. Here 250 ml of water is taken in each beaker. 250 ml of water. Okay. Water. Is 250 ml of water. H2O. Okay. Here, for the A beaker, sodium metal is added, sodium Na. And for the beaker B, calcium metal is added. Okay. So, what are the reasons for the observation that have been noticed here? When the sodium is added to the water, there is a vigorous reaction takes place with in between the sodium and water, which is the highly exothermic process, which is highly exothermic process where large amount of heat is released with the light. Large amount of heat is released with the light. So that is the exothermic process. Because there is, when the water reacts with the sodium, the exothermic process that results in the formation of sodium hydroxide. Then when the calcium is added to the water, it forms the calcium hydroxide and small amount of hydrogen. Okay. So this calcium hydroxide that forms the white precipitate. When the calcium is added to the water, white precipitate is formed. That is the calcium hydroxide. Okay. So this type of the reaction takes place when these both metals are added to water. Draw the diagram of arrangement of apparatus to show the action of steam on metal and label the metal sample. Yes, we have solved this question in the last class only. Again, this question is repeated in many question paper. I repeat once again, please practice this daily and mention all the labelings. So that is also very important. Next question. What are ionic compounds? Write any four properties of ionic compounds. What are ionic compounds and write any four properties of ionic compounds here. An ionic compound is defined as the compound formed by the oppositely charged ions which attract each other to form a chemical bond. So that is the definition of the what are ionic compounds. Next, what are the properties of the ionic compounds? Yes, already we have discussed the properties of the ionic compounds. That is what is the physical nature and what are about the melting and boiling point and about the solubility, then about the conduction of electricity. So these are the four characteristics of the ionic compounds. In short, you can write that. Okay, no need to write in detail all these points. You can write it shortly. Next question. Name two metals which are kept stored in kerosene oil. Write the four physical properties of metals. Name any two metals, that is sodium and potassium. Sodium and potassium, which are stored in kerosene oil. Write any four physical properties of metals. Here, four physical properties of metals. Metals, they are having the ductility and malleability. They have ductility and malleability. Then they are lustrous in nature. They are having the shiny outer surface. Shiny outer surface. Then they are hard and in a solid state in the room temperature except mercury. They are hard and solid state in the room temperature except mercury, and they have the sonorous property, means they produces the sound when hit into the uh, hard substance, hit by the hard substance. They are sonorous in nature. So these are the some characteristics, physical properties of the metals. Okay. Yes, can see the answer here. Metals are malleable and ductile. Metals are good conductors of heat and electricity. Yes, these are the two important characters. And metals are lustrous, means like shiny and can be polished. Metals are solids at room temperature except the mercury, which is a liquid at room temperature. Metals are tough and strong. So these are the some physical properties of the metals. Next question. Draw the diagram of arrangement of apparatus that showing the electrolytic refining of copper and label the acidified copper sulfate solution. This is also one of the important diagram. Here, the diagram is like this. Here, acidified copper sulfate, so that you have to mention. And remaining all here cathode. This is the cathode and this one is the anode. Anode. Acidified copper solution. Then this is the tank and these are the impurities. Okay. So that is also called as the anode mud. It is also one of the important diagram. Please label these all labelings and very easy and very important diagram. Next question. Explain the electrolytic refining of metal. So here, what is electrolyting? Lytic refining of metal that we have to explain. Many metals such as copper, zinc, and nickel, silver, gold are refined electrolytically. Here, in this process, the impure metal is made anode and the thin strip of pure metal is made as cathode. A solution of metal salt is used as an electrolyte. On passing the current through the electrolyte, the pure metal from the anode dissolves into the electrolyte and equivalent amount of pure metal from the electrolyte is deposited on the cathode. The soluble impurities go into the solution whereas the insoluble impurities they settle down at the bottom of the anode and are known as anode mud. So this is the electrolytic refining of the metal. So one of the important question, please note down this. Next question, explain the extracting of metal from top reactivity series. So how to extract the metal from the top reactivity series? Here, the metals high up in the reactivity series are very reactive. They are more reactive metals. They cannot be obtained from their compounds by heating with the carbon. For example, carbon cannot reduce the oxides of sodium, magnesium and calcium and aluminum, etc. So to the respective metals. So this is because these metals have more affinity for oxygen than the carbon. They have more affinity towards the oxygen. Then these metals are obtained by electrolytic reduction. For example, sodium, magnesium and calcium are obtained in the electrolysis of the molten chlorides. So these metals are deposited at the cathode, the negatively charged electrolyte, whereas the chlorine is liberated at the anode. So the reaction takes place at the anode and cathode. So that is represented here. So like this, the metals of high reactivity series are refined. They are extracted from this method. Explain how do metals react with the solutions of other metal and metal salts with example. Please understand the question. Explain how do metals react with solutions of other metal salts with example. Reactive metals displace the other metals from their solution. Iron displaces the copper from its solution here. For example, copper sulfate solution, when the iron is added to this solution, here copper is displaced, iron sulfate is formed, and copper is displaced from this solution. Okay, so that is the reaction. What happens when the metal reacts with acids? So just imagine zinc is the metal. So when the metal, just write the metal reacts with the acids. When metal reacts with the acid, it forms the salt and hydrogen gas, which releases the hydrogen gas. Okay. Then, for example, zinc metal reacts with H2SO4, sulfuric acid, which forms the zinc sulfate, and the hydrogen gas is released. So this is the, when metal, zinc is the metal and sulfuric acid is the strong acid, it forms the, that is salt, zinc sulfate is the salt and hydrogen gas is released here. Okay, so that is the reaction. Next question. Give reasons why copper is used to make the hot water tanks and not steel, an alloy of iron. So what is the reason for this? Here, copper does not react with cold water or hot water or steam. However, iron reacts with the steam if the hot water tank are made of steel. Okay. So an alloy of iron, then the iron would react vigorously with the steam and form from the hot water. So here when the iron, when it reacts with the water, it forms the ferrous oxide and water. But when the copper reacts with the water, there is no reaction. Okay. So that is why copper is used to make the hot water tank than the not steel. What are amphoteric oxides? Give two examples of amphoteric oxides. Here, note down the question. What are amphoteric oxides? Give two examples of amphoteric oxides here. The oxides which behave as both acidic and the basic oxides are called amphoteric oxides. When it reacts with the acids, it forms the salt and water, and when it reacts with the base, it also forms the salt and water. So it is called as the amphoteric oxides. So it behaves like both acidic and the basic oxide. Examples here, zinc oxide and the aluminium oxide. So these are the amphoteric oxides. Next question. Name two metals which will displace the hydrogen from the dilute acids and two metals which will not. Name two metals so which displace the hydrogen from the dilute acids, means HCl. HCl is the strong acid, so acetic acid. And two metals which will not displace the hydrogen. Here, iron and aluminium will displace the hydrogen from the dilute acids because being more reactive than the hydrogen. But mercury and the copper cannot displace the hydrogen from the dilute acids because being the less reactive than the hydrogen. Yes, please note down this question. Note down the answer also. Next question. In the electrolytic refining of metal M, what would you take as the anode and cathode in the electrolyte? Please note on the question. We don't know which metal we are refining, electrolyting refining of the metal, which we have to take as anode and cathode and the electrolyte. Here, in the electrolytic refining of metal M, impure metal is connected to the anode and pure metal thin sheet is connected to the cathode. That is the how anode and cathode are connected. Electrolyte is acidified copper sulfate solution. Iron and aluminium will displace the hydrogen from the dilute. Sorry, not this one. In the electrolytic refining of metal M, impure metal is connected to the anode and pure metal thin sheet is connected to the cathode. Okay, so this is the answer for this question. Please note this one, not this one. Okay, so this is very important. In the electrolytic refining of metal M, impure metal is connected to the anode and the pure metal is connected to the cathode. Electrolyte is acidified copper sulfate solution. Here you can see the which one is used as anode, cathode and the electrolyte. Okay. Next question. Pratyush took the sulfur powder on a spatula and heated it. So just imagine this is the spatula. Okay. So this is the spatula. He collected the gas evolved by the inverting the test tube over it as shown in the figure below. See here. So this is the spatula. He took the sulfur and heated the gas collected, that is gas is collected inside the test tube. Okay. So this is the burner. So what will be the action of gas on dry litmus paper, moist litmus paper? Write a balanced chemical equation taking place. Here, sulfur is taken. So sulfur is taken in this. And what is the action of dry litmus paper, moist litmus paper, and you have to write the balanced chemical equation here. Here, no action on the gas on dry litmus paper because there is no formation of the ions takes place. So there is no there is no action on the dry litmus paper. In case of the moist litmus paper, it turns red because sulfur is a non-metal and oxides of non-metal are acidic because this sulfur oxide, that is the acidic in nature. So it turns the moist litmus paper into red. Then what is the chemical reaction takes place here? Sulfur plus oxygen, which forms the sulfur dioxide. So that is the chemical reaction. Please note down this question. Yes, so this is the answer with reasons. State two ways to prevent the rusting of iron. How rusting of the iron is prevented? Here we can prevent the rusting of iron by painting or here oiling, greasing or painting. By applying oil, grease or paint, the surface becomes waterproof. The moisture and oxygen present in the air cannot come into direct contact with the iron. Hence, rusting is prevented. So, like this, rusting of iron is prevented. And one more method is galvanization. So, what is this galvanization process? An iron article is coated with layer of zinc metal which prevents the iron to come in contact with the oxygen and moisture, hence rusting is prevented. So these are the two important methods of uh, uh, preventing the rusting of iron. So very important question. And what is galvanization? That is also asked in the exam. What is galvanization process? Next question. What types of oxides are formed when non-metals combines with oxygen? See the question. What type of oxides are formed when non-metal combine with the oxygen? When the non-metals combine with oxygen, non-metal for example, carbon which combines with the oxygen which forms the carbon dioxide. Okay, so this is the example. Or acidic oxide are formed. For example, nitrogen dioxide, sulfur, nitrogen oxide, carbon monoxide. So these all are the neutral oxides. Give reasons. Platinum, gold and silver are used to make the jewelry. Sodium, potassium and lithium are stored under the oil. Aluminium is highly reactive metal yet it is used to make the utensil for cooking. And the fourth one, carbonate and sulfide ores are usually converted into oxides during the process of extraction. Yes, please note down this question. So you should give the reasons for each question. Platinum, gold and silver are used to make the jewelry because platinum, gold and silver are they have they are shining metals and less reactive and they do not corrode easily. So what are the properties used here? They are shining metals and less reactive and they do not corrode easily. Then sodium, potassium and lithium are stored under the oil because this sodium, potassium and lithium are they are highly reactive metals. They vigorously react with the air and catches the fire. So hence they are protected inside the kerosene to prevent the accidental fire. So that is the reason. Please note down this. Next one. Aluminium is highly reactive metal and it is used to make the utensil for cooking. So what is the reason behind this? Aluminium is highly reactive metal. It does not rust. So which will not undergo rusting process because it combines with the oxygen and forms the aluminium oxide. The protective oxide layer prevents the metal from the further oxidation. Hence, aluminium is good and also aluminium is good conductor of heat. So that is very important. Aluminium is good conductor of heat. Hence, it is used as a um, hence it is used to make the utensil and yes it is highly reactive but it forms the aluminum oxide layer so which will not undergo the further oxidation process. Then the last one, carbonate and sulfide ores are usually converted into oxides during the process of extraction. So what is the reason behind this? Here, the metals in the middle of the reactivity series such as iron, zinc, lead, copper are moderately reactive. So these are usually present as the sulfides and carbonates in nature, carbonate ores. Okay, so iron sulfides like this. It is easier to obtain the metal from its oxide compared to the sulfides and carbonate. So that is the easy method when it convert into oxide. So, prior to the reduction, the metal sulfides and carbonates must be converted into the metal oxide. So, that is the main reason. So, these four questions are very important questions. So, please write the correct reason for these all questions. Okay. And these are also very repeatedly asked questions also. Okay. So, thank you students. I will stop the class here. We'll continue in the next class. Okay. Thank you.